Okay, guys, successive differentiation. So, so if y is a function of x, okay, and if I want to differentiate y with respect to x, it's dy by dx, right? And we'll represent the right hand side as f dash x. And if you want to do it one more time, that means if you want to differentiate now, if it is differentiated further, that means differentiation of the differentiation, then it's f double dash x, right? So here we will write this as d2y by dx square equals to f double dash x, right? Again, if I differentiate it, d2y by dx square, and if I differentiate this with respect to x, this will be equal to d3 by d3y by dx cube, right? This can keep going on, and we can write a general form for nth derivative of y with respect to x, right? Which will be equal to d to the power n y by dx to the power n, right? So, so this is a general expression for nth derivative of y with respect to x. Now, Leibnitz theorem is about finding the nth derivative of product of two functions. Okay, so if I have u and v both are function of x, okay, and I want to find the nth derivative of a product of u and v with respect to x, then by by Leibniz theorem it is nc0 into nth derivative of u into v plus nc1 into n minus 1 n minus 1th derivative of u into first derivative of v1 plus nc2 into u n minus 2 derivative into second derivative of v plus so on ncr u n minus r u n minus r derivative into v r derivative, and the last term will be ncn into u into nth derivative of v. It's quite similar to a binomial expansion. We explain this with the help of an example because it looks a little ambiguous. So let's say u is equals to x and v is equals to sine x. So u into v is x sine x, right? And you want to find the fourth derivative of x sine x. So how shall we approach it? So first of all, to appreciate this theorem, Leibniz theorem, let's solve this. Let's solve this manually. Manually means the way we normally solve for a derivative, right? So x sine x. So if I differentiate x sine x, so x into differentiation of sine x, that is cos x, plus sine x into differentiation of x, that is 1. That's the first. First this is the first derivative, right? And let me find the second. Let's find the second one. Second derivative will be differentiation of first derivative, x cos x plus sine x by x, and so this is d of x cos x plus by dx plus differentiation of sine x, by x. Okay, so this will be cos x. This will be x of minus sin x. X, so x remains fixed, and differentiation of cos x is minus sin x, and cos x into 1, right? Because differentiation of x is 1. So minus x sin x plus 2 cos x. And we find the third derivative, and which will be differentiation of this expression, which will be um, differentiation of minus x sin x plus 2 cos x divided by x. That is minus x will remain fixed. Differentiation of sin x will be cos x plus 2 minus sin x. Oh, I made a mistake. I need to. So, okay, where was I? Yeah. So minus x into cos x, then sin x will remain fixed. So this will be, then sin x will remain fixed. And what's the differentiation of minus x? Minus x differentiation is minus 1 plus 2 of minus sin x, right? Minus x cos x minus of sin x minus of 2 sin x, right? This will be minus x cos x minus 3 of sin x. Okay, the last one, that's the fourth derivative by x. Okay, so differentiation of minus x cos x plus 3 sin x. So we'll take the minus sign out. X cos x differentiation we saw here, so it's minus x sin x plus cos x, and differentiation of sin x is cos x, right? So x sin x minus cos x plus 3 plus minus 3 cos x, right? This is our fourth derivative. Now I hope you realize how long it was. Let's do the same thing by applying this theorem. So u into v is equals to x sin x, right? And we want to find the fourth derivative. So let's put the values. So 4c0 into fourth differentiation of u into fourth differentiation of u. So that is fourth differentiation of our first function, that is 4, right? Into v. What is v? Sin x plus 4c1 u n minus 1, that is 4 minus 1 is 3. So third differentiation of x into v1, that is first differentiation of sin x, plus 4c2 and 4 minus 2, that is second differentiation of x into second differentiation of sin x, okay, plus 4c3 third differentiation of x into third differentiation of sin x, plus 4c3 into u of n minus r, that means 4 minus 3. So first differentiation of sin x and third differentiation of first differentiation of x and third differentiation of sin x, and 4c4 u, that is x into fourth differentiation of sin x, right? If we solve this, so first of all, fourth differentiation of sin x will be 0. Third differentiation of sin x will also be 0. And second differentiation will also be 0, right? Because first differentiation of sin x is only 1. So if we differentiate it further, it becomes 0, right? So we don't need it. So are all these three terms will become 0. So we have to deal with only these two. So 4c3, first differentiation of x is 1, and third differentiation of sin x. The third differentiation of sin x, that is differentiation of sin x, will differentiate sin x once, so I'll get cos x. And then if I differentiate it again, I'll get a minus sin x. And then if I differentiate it again, I get a minus cos x. So that's my third differentiation for sin x. Minus cos x plus 4c4 into x, fourth differentiation of sin x. We found the third differentiation here. We just need to differentiate it one more. So cos x of minus sin x. So differentiation of cos x is minus sin x, and with this one more, here with one more minus sin, the fourth differentiation of sin x becomes sin x, right? So what about these 4c4 and 4c3? 4c3 is 4 factorial by 4 minus 3 factorial, 1 factorial into 3 factorial. That gives me 4 into 3 factorial. If I solve this, I get minus 4 cos x. And 4c4 is 1 into sin x, right? So x sin x minus 4 cos x. So what did we got here? Here in fourth derivative of the here. So yeah, here also I didn't add these two. So x sin x minus 4 cos x. Right? So here also x sin x minus 4 cos x. I hope you appreciate the fact that maybe the method looks really lengthy, so much that you will use the normal regular way only. But it's not that difficult. But because if you put you put the values in right order, half these values becomes half these half these values become 0, right? And then we are left with only we are and then we are left with only two terms. And if you solve this, you will get the answer quickly, right? It just needs practice, not really learn. Like if you really see a pattern here, n minus 1 and then n minus 2, and then in the end, all the n goes to v, because as we are decreasing 1 with each term, this one goes to v, and the last term is vn with u, and here it's un with v, right? If you can remember this, and then with practice you will be able to look at the expression, and you can, so with practice you will be able to look at the question and tell the answer, because